Hi guys, this is O-level chemistry, paper 11, November 2022, question 21. A sample of sulfuric acid is added to 10 grams of zinc granules. A reaction occurs and a gas is produced. Okay, this gas would be hydrogen gas because acid is reacting with metal. The rate of reaction is increased if a small amount of copper is added. Okay, the copper is unchanged after the reaction. Okay. Which statement about this reaction is correct? So if you're adding copper, it is increasing the rate of reaction and it remains unchanged. That means copper is acting as a catalyst. Which statement about this reaction is correct? A, copper acts as a biological catalyst in this reaction. No, it is acting as a catalyst, not as a biological catalyst. So B, copper lowers the activation energy of this reaction. That is the purpose of a catalyst. We add a catalyst because it lowers the requirement of activation energy. C, the rate of reaction is greater as the particle size of the zinc is greater. No, a reaction would be rate would be greater if the particle sizes are smaller, not greater sizes of particles. Next, the rate of reaction is greater if the pressure is increased. A pressure has no effect on the rate of reaction. Pressure has an effect on an equilibrium position of a reversible reaction, but not on the rate of reaction. So here, option B is the correct option for this question. Question 22. The rate of reaction between magnesium and dilute hydrochloric acid is investigated. The equation is shown. Okay, magnesium reacts with 2 moles of HCl, producing magnesium chloride and hydrogen gas. A known mass of magnesium is added to an excess of dilute hydrochloric acid. The concentration of the hydrochloric acid and the volume of hydrogen produced is measured at regular time intervals. Which pair of graphs correctly show the experimental results? Okay, so we have concentration of HCl and we have volume of hydrogen gas being produced. So initially the concentration of HCl would be maximum, and when this ends, the experiment ends, the concentration of HCl would be zero. No, 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 no. When all the magnesium is used, because they said a known mass of magnesium added to excess of dilute hydrochloric acid. You need to remember that if HCl is in excess, its concentration cannot reach zero. So option A is incorrect for concentration of HCl. Volume of hydrogen, this is correct because slowly the hydrogen gas will be produced, then it will increase and then it will reach a maximum. So the graph for hydrogen is correct here. In option B, the concentration is touching zero, so this is wrong. And there is a gradual increase and then an exponential increase in, or rather overall, this graph shows an exponential increase in hydrogen gas. No, C, the concentration of HCl reaches a particular value when the reaction ends. Yes. And the volume of hydrogen increases exponentially. No. Option D, the concentration reaches a particular value when the reaction ends. Yes. And gradually the concentration of hydrogen increases until it reaches a maximum value where it becomes still, or rather a plateau region is reached. So this is also correct. So for this question, option D is the correct option. Question 23. In which reaction is the underlying substance reduced? So in A, calcium carbonate, calcium has a 2 positive charge and it goes to calcium chloride in which calcium has a 2 positive charge. So nothing is happening to the calcium ions here. In B, Cu2 plus is converted into Cu metal. So 2 plus charge becomes a charge of 0. So this is reduction. Next, carbon in carbon monoxide has a charge of +2 and carbon in carbon dioxide has a charge of +4. Going from +2 to +4 is oxidation. Zinc metal has a charge of 0 and in zinc sulfate, zinc 2 positive ions are present. Going from a charge of 0 to 2 positive is oxidation, not reduction. So the correct option for this question is option B. Question 24. Which change involves reduction? Calcium carbonate to calcium oxide, there is no change taking place because calcium has a two positive charge in both the compounds. Copper to brass. Copper is a metal and brass is a mixture of copper and zinc, so nothing is happening to copper. Ethene to polyethene. So ethene has a double bond, polyethene has single bond. The double bond is opening up, nothing is happening to the oxidation state of carbon or hydrogen. Sand to silicon. Sand contains SiO2 and it is converted into silicon. Silicon is an element. An element has a charge of 0, whereas in SiO2, oxide ions have a charge of -2, and there are two oxide ions, so a total charge of -4, which is balanced by the charge on the silicon ion, which has a charge of +4. So we have +4 going to 0. This is reduction. And the question asks which change involves reduction. So option D is the correct option for this question. Question 25. Thiosulfide ions H2O3 2- react with iodine in aqueous solution. And the equation is given. In this reaction, the thiosulfide ions dash represented by 1, electrons are dash represented by 2. Which word correctly completes gaps 1 and 2? So gap 1 says gain and loss, you lose. Option 2 says oxidized or reduced. So we need to find out the oxidation state of sulfur in both of these ions. So we have got S2O8 2- ion, and we have got S4O6 2- ion. So now we need to find out the oxidation state of sulfur. How do we do that? We draw a bracket here, right? Oxygen is in the form of oxide ion. It has a charge of -2 and sulfur has a charge of X. So we form an algebraic expression. So we have 2 moles of sulfur, 2 atoms of sulfur rather. So 2x, 8 to the 16, -16 equals overall charges -2. So this becomes 2x equals -2 plus 16. 2x equals plus 14. Oh, I'm sorry, this S2O3, not S2O8. We need to correct this. S2O3. So let's redo this. We have 2x minus 3 to the 6 equals -2. So 2x equals -2 and plus 6 becomes +4. X would be equal to +4 divided by 2. This is equal to +2. So the charge on sulfur in S2O3 is +2. And now let's work out the charge on sulfur in S4O6. Is this incorrect? Yes. Okay. So again, we draw a bracket here. The charge on the oxide ion is -2. The charge on sulfur is X. So the algebraic equation becomes 4x minus 6 to the 12 equals -2. So 4x would be equal to -2 plus 12. So 4x equals plus 10. X would be equal to plus 10 divided by 4, and x gives us a value of plus 2.5. So we have the oxidation state of sulfur going from +2 to plus 2.5. There is an increase by 0.5. An increase in the positive charge means oxidation is taking place. And when oxidation takes place, electrons are lost. So, based on this, the blank one would have lose as the option, not gain, and blank 2 would have oxidize as the option and not reduce. So this makes option C the correct option for this question. Question 26. The equation shows a reaction in the contact process. Okay, this is an exothermic reaction and it is reversible. Okay, which change would move the position of the equilibrium to the left? Okay, adding more oxygen. Oxygen is a reactant. If we increase the concentration of reactants, the equilibrium will be favored in the forward direction. That means it will be favored towards the right. Increasing the pressure. An increase in pressure favors the equilibrium towards the side with the lesser number of moles. So number of moles of reactants are 2 plus 1, 3, and the moles of products are just 2. So an increase in pressure will shift the equilibrium towards the right. Increasing the temperature. An increase in temperature favors the equilibrium towards the endothermic side of the reaction. This question shows that the forward reaction is exothermic. So an increase in temperature will favor the endothermic side. So it will not favor the forward reaction, it will favor the backward reaction. So equilibrium will shift towards the left. And removing SO3 from the reacting mixture. If we decrease the concentration of products, the equilibrium will shift towards the right in order to balance out the quantity of product. So equilibrium will shift towards the right in this case. So based on our findings, the correct option for this question is option C. Question 27. Some medicines contain the magnesium salt of a fatty acid. The fatty acids are members of the homologous series of carboxylic acids and contain one carboxylic acid group. What is the carboxylic acid functional group and how many moles of fatty acid react with 1 mole of magnesium? Okay, the functional group is COOH. So options A and B contain COOH. Options C and D contain CH2OH, which is an alcohol group. So these options have been eliminated. Now, moles of fatty acids. So we have this combining with magnesium. So magnesium has an ion which has a charge of +2. We have carboxylic acids that have a charge of -1 in the ionic form. So we will have two carboxylic acid functional groups combining with magnesium. So moles of fatty acid would be 2. So this makes option B the correct option for this question. Question 28. Sodium sulfate Na2SO4 and sodium hydrogen sulfate NaHSO4 can both be prepared using aqueous sodium hydroxide and sulfuric acid. Okay, so here NaOH and H2SO4 for Na2SO4 is in the ratio 2:1 and NaOH and H2SO4 are in the ratio 1:1 for the preparation of NaHSO4. Okay, 50 cm cube of 1 mole per dm cube sodium hydroxide is used each time. So let's calculate the number of moles of NaOH. So we have a concentration of 1 mole per dm cube. That means 1 mole in 1000 cm cube. How many moles would be present in 50 cm cube? Because we are using 50 cm cube each time. So this will give us 50 upon 1000 into 1, which will give us a value of 0.05 moles of NaOH being used. Okay. Now, which row shows the correct volume of 1 mole per dm cube sulfuric acid required to prepare a sample of sodium sulfate and a sample of sodium hydrogen sulfate? So we need to perform two separate calculations. So for the first column, we will have moles of sulfuric acid in the ratio NaOH is to H2SO4 is 2:1. So moles of NaOH is 0.05. So moles of sulfuric acid would be half into 0.05, which will give us a value of 0.025 moles. 0.025 moles. Now we need to calculate the volume of sulfuric acid because we now have the moles. So the concentration of sulfuric acid is 1 mole per dm cube. That means 1 mole are present in 1000 cm cube. And we have 0.025 moles being used. So what volume will contain these many moles? So the calculation would become 0.025 divided by 1 multiplied by 1000. This would give us a value of 25 centimeter cube. So options A and B both have 25 cm cube. Options C and D are wrong because they have a value of 50 cm cube. So now we perform another calculation for the second column. In this, the molar ratio of NaOH is to H2SO4 is 1 is to 1. Therefore, moles of H2SO4 is equal to 0.05. Now we have the moles of H2SO4. So now we calculate the volume. So the concentration of the acid is 1 mole per dm cube, meaning 1 mole in 1000 cm cube. So 0.05 moles would be present in what volume? So the calculation would become 0.05 divided by 1 multiplied by 1000, and this will give us a volume of 50 cm cube. So option A has a value of 50, option B has a value of 12.5, which is wrong. This makes option A the correct option for this question. Question 29. Which substance reacts with dilute sulfuric acid in the preparation of a pure sample of lead-2 sulfate? Okay, lead-2 sulfate is an insoluble salt. So if we have preparation of lead-2 sulfate using sulfuric acid, so this would be acid plus soluble salt. So these are our requirements. So let's look at the options. A, aqueous lead nitrate. All nitrates are soluble. So this option is correct. Lead foil. Lead foil is lead metal, not a soluble salt of lead. C, powdered lead carbonate. Lead carbonate is insoluble, which will not be the correct option here. And option D is powdered lead oxide. Again, lead oxide is insoluble. It will not be the correct option. Thus, this makes option A the correct option for this question. Question 30. Which statement about sulfuric acid is correct? In the manufacture of sulfuric acid, iron is used as a catalyst in the contact process. No, iron is not used. The catalyst used is vanadium 5 oxide or V2O5. B, sulfuric acid is used in some batteries. Yes, it is used in car batteries. C, sulfuric acid is used as a fertilizer. No, sulfate salts are used and ammonium salt. So ammonium sulfate, not sulfuric acid directly. In fact, if you add sulfuric acid, it would leach away the minerals present in soil. Sulfuric acid is used as a food preservative? No. Sulfur dioxide is used as a food preservative, not sulfuric acid. So this makes option B the correct option for this question.